Hi everyone, welcome to this video. We will look at question 4 next. This is of the, let me write that down again, FAMS sample questions, which you can get from the SOA website. The solutions are also there. We are going to talk through this problem and let's start, yeah? Question number 4, we are given low hazard risks have an exponential claim size distribution with mean theta. Again, right? Low hazard risks have an exponential claim size distribution with mean theta. Medium hazard risks have an exponential claim size distribution with mean 2 theta. Okay, so let's take note of that. This is theta, 2 theta. And high hazard risks have an exponential claim size distribution with mean 3 theta. Okay. No claims from low hazard risks are observed. 3 claims from medium hazard risks are observed of sizes 1, 2, and 3. And 1 claim from a high hazard risk is observed of size 15. Okay, calculate the maximum likelihood estimate of theta. Okay, so as usual, we will start with the likelihood function. So we can move up the screen a bit. Okay, we'll start with the likelihood function. And then we'll create the log likelihood function and so on. So let's see. Let me erase. No. Let me erase this. Okay. Good. So let's talk about, if you look up the formula book, if you have forgotten, otherwise, you know, the PDF of your exponential distribution is 1 over theta e to the power minus 1 over theta x, right? So that's a standard thing. You will find it in your formula, in your tables provided, your formulas provided in the FAMS exam, the density function of your exponential distribution. Okay, good. When you have an exponential distribution with mean theta. So we're using that. And so take note of the fact that we are starting with your medium size, yeah, medium hazard risk. Okay, the low hazard risk, there are no observations. Medium hazard risk, we have 3 observations, 1, 2, and 3. So that's what you see here. Okay, when we set up your likelihood function, L of theta, first one here, this 1 over, remember this is the mean, right? The mean of your medium hazard is 2 theta. So 1 over 2 theta e to the power of minus 1 over 2 theta times, that's the times of 1 here because the first value is 1. So I didn't write that down. And then you do the same. The second value that you observe is 2. That's what you see here. Okay, 2. And the third value that you observe is 3. So nothing difficult here. We're just using the PDF. If you've forgotten, you can just look it up in your formula book. And then you have a high hazard risk. You have 1 observation, which is 15. So you have 1 over, well, if you like, you can think of this 1 over mu e to the power of minus 1 over mu x and so on. Yeah. So that's entirely up to you. I can tell you the page it's on, right? You can look it up. If you look under continuous distributions in your tables, okay, you'll find it. Let's see, you'll find it. I think you can find it on your, it's found on page 8, right? It's found on page 8. So they give you the density function of the exponential distribution and so on, yeah? The CDF and so on. So anyway, we don't need all those things. Once we have this set up, all we need to do is, we're trying to find the MLE of theta, so we don't have to worry about the constants, right? So if you want to be, if you want, you can keep your constants. It's not going to make any difference. I've just dropped the constants. If you don't want to drop the constants, you can write it as, you can use a K here if you like. I didn't even bother, yeah, because it's not going to affect me. So let's see. Let me get rid of that. So you clean this up. Okay, you clean this up. You have a 1 over theta here. Okay, you have 1 over theta here. 1 over theta, 1 over theta, 1 over theta. I have this thing here. Again, I've ignored the constants, right? And then we need to take, okay, add all these up. Okay, add all these up. And you'll get e to the power of minus 8 over theta. Not hard to do. Okay, so this is the same as theta to the power of minus 4. Okay, so this is theta to the power of minus 4 and e to the power of minus 8 over theta. So pretty good. This is your likelihood function. Again, like I said, I've dropped the constants. It's not going to bother me. Then I take my logs. Okay, so I'll get my log likelihood. When you take your logs, you'll get minus 4 log theta minus 8 over theta. Okay, and then once you get your log likelihood, you take the derivative. Take the derivative. When you do that, you'll get minus 4 over theta plus 8 over theta squared. And you set your derivative to 0. Set your derivative to 0 and you solve for theta and you get theta equals to 2. Answer B. And we are done. Yep. Thank you very much for watching.